Today I will share with you how to develop your project network and also your Gantt chart using POM QM. By now you should have installed POM QM into your computer, and so I will share my screen so that I can illustrate to you how to work with POM QM. So using the project management textbook, the 5th edition, we will look at problem number 10. Jay Wald is a project management of print software incorporated. He wants you to prepare a project network and compute the early and late and the slack activity times. Would also like you to determine the planned project duration and then identify the critical path. His assistant has collected the following information for color printer drivers software project. Here are the data. This is the ID for each node. Here are the description of each node or activities. Here are the predecessor nodes information, and this is the time. These are the times for each activity. As you can see here, the data is structured in a node pattern where the activity is developed on node or is identified on node. So we call this activity on node AON. So the activities are on each node. Information about the activity is presented on each node. So in that case, you would like to use, and here we only have one time estimate. We have another option of triple time estimate. This is when you have optimistic time, most likely time, and pessimistic time. So if you have data where there are some uncertainty and there are some variation between optimistic and pessimistic, then you will need to use triple time estimate. But here we only have one time estimate. So we choose project management, and then we choose single time estimate. Okay, and then here, because the activity is on node, the activities are on node, so we use start and actually we can use immediate predecessor list in this case, because we can immediately see the predecessors. Later on, I will illustrate to you situation where we use start and end node. This would be appropriate for condition where we have activity on node, activity on arrow, AOA. So when the data is presented in an activity on arrow structure, where the activity is represented on the arrow, then we will use start and node numbers. But here, the activity is on arrow, so we can use immediate predecessor list. Here is a question of how many number of activities. Let me just say here, problem 10. Number of activities, we have 2, 4, 6, 8, 10, 12. So we have 12 activities here. And the name of the nodes, the ID of the nodes are A, B, C, D, E. Okay, so we put in A, B, C, D, E, and then we just click OK. All right, so for activity A, the time is 8. See, I took this from the problem. Yeah. Time is 8. The predecessor, there is none. B, okay, time is 2. Predecessor is A. So we type A there. Okay. C, time is 3. Predecessor A. D, time is 60. Predecessor is A. E, time is 60. Predecessor is B. F, time is 2. Predecessor is C. G time is 2, predecessor is D. H time is 20, predecessor is E and F, so we have E and we have F. I, predecessor is 10, predecessor is G. Okay, J time is 10, predecessor is H and I. K time is 12, predecessor is J, and L time is 3, predecessor is K. So the method single time estimate, because there's only one single time, and we're using immediate predecessor list because it's most appropriate when we are working on an activity on node structure. Like this one, the activity is on the nodes. Once we are done, we click solve, and then it gives us the data. Remember, the problem asks us to prepare a project network, compute the early, late, and the slack activity time. So here we have our early start. This is the early start times for each activity. This is the early finish times for each activity. Okay, as you can see, we calculate the early finish time is the early start plus the activity time, giving us early finish. Yeah, early start 8 plus 2 is 10, and so on. Late start is the late start time, so that the project will not finish beyond the planned time. So this is the latest time to start each activity, and this is the latest time to finish it. The early start and early finish is calculated using forward method, while the late times is calculated using the backward method. And you would have known how to calculate that using the textbook. But anyway, and then it asks us to calculate the slack activity times. Here are the slack. Slack is when there is a difference between the early start and late start. For example, for activity C, early start is 8, late start is 65, so we have 57 slack days, meaning activity C can be delayed for 57 days, the latest, so that the project will not be delayed. Okay, and if you see 0 slacks, these are the activity that cannot be delayed. There is no slack at all, so it cannot be delayed. If it is delayed for a single day, it will push the project back by 1 day. While the activities with slack days will indicate activities that can be delayed as many or as much as the slack days. Delays beyond the slack days will cause the project to be delayed by the additional incremental delays above the slack time. Okay, so those are the early, late finish, and the slack times as required by this problem. Compute the early, late, and slack activity times. Now, what about the project network? It asks to prepare a project network. How do we find that? We go to solution, click solution, and then we click chart. Okay, and then we click chart, and here we have a few charts here. If you click on the first chart, precedence graph, this gives us the project network. It gives us the precedence chart. Yeah, as you can see, A is the beginning, and then B, C, and D is the successor, and so on. So this is the chart. If you're gonna develop this using the 9-cell node model that we studied in the textbook, you can just simply change this circle with the 9-cell node, and you put in the data as we have studied the chapter. Okay. By the way, if you look at the red arrows, these represent the critical path. So the critical path is A, B, E, H, J, K, L. This critical path has nodes that have 0 slack time. Okay, it has 0 slack time, so they cannot be delayed. All right, so once we're done with that, we can also see the Gantt chart. Here is the Gantt chart. Okay, and in the Gantt chart, you see the red bars. These represent the critical activity where there is no slack. There's no slack. While the blue is the early times, early start and early finish, and the pink is the late start and late finish. That means you have a big slack in between. In other words, activity C can start as early as day 8, or it can start as late as day 57, and it will still be finished on day 68 without delaying the next activity that depends on it, which is activity G. Okay, which is activity. Now, or which is activity, was it F? Yeah, G, yes. So, so you see the Gantt chart gives us also a good project planning visually. So with POM QM, you can create the precedence graph. You can create the Gantt chart showing the early times and finish time and showing the critical paths. But also it gives us the calculation of time calculation, where you have the activity time, early start, early finish, late start, late finish, and the slack time. Okay, we will move on to the next problem that utilizes triple time. So let's move to chapter 7, where we have project evaluation and review technique, particularly when there are uncertainties. Uncertainty means that there are possibility of the project duration could be shorter or it could be longer, etc. So let's look at it. We have 3 times estimate, in which the first one is called the optimistic time. The second one is called the most likely time, or M, and the third one is the pessimistic time. Now go ahead and study chapter 7, especially the appendix for project evaluation review technique, and see how TE is calculated. TE is the weighted average of these 3 times. So you can calculate it manually. TE is the weighted average of the 3 times, while this one is the variance for each activity. Okay, and as you can see, the activity is on arrow between 1 and 2. See, this is node 1 and node 2. Activity, the first activity is between node 1 and node 2. And so this is what we call the activity on arrow, AOA. Okay, AOA network, activity on arrow. You can also represent this as an activity on node. This is the activity on node. So you can put this data into POM QM using AOA network, or you can use AON network here. Let me illustrate how to do this using both approach. Let me show you how to do it using single time first, because single time is most appropriate for AON. Well, sorry, this is not single time, this is triple time estimate. Okay, but if you use this data as represented by this table will actually ask you to use start and end node numbers. If you're using information from here, then you will need to use immediate predecessor list. But let's use this one here, yeah? The activity is represented on arrow between 1 and 2, 2 and 3, and so on. So we will choose start and end node. Okay, and let's just use A, B, C, D, E, that's fine. How many activities are there? 2, 4, 6, so we have 6 activities. Okay, we click OK. So for activity A, the starting node is 1, right? Start node is 1, end node is 2. The optimistic time is 17, most likely time is 29, and pessimistic time is 47. Okay, for activity B, starting node is 2, end node is 3, most likely optimistic time is 6, most likely is 12, and pessimistic is 24. Activity C, its starting node is 2, ending node is 4, optimistic time is 16. Okay, again, C, starting node is 2, end node is 4, optimistic time is 16, most likely time is 19, and pessimistic time is 28. And activity, start node is 3, end node is 5, optimistic time is 13, most likely 16, and pessimistic time is 19. And then activity 4 or E, starting node is 4, end node is 5, optimistic time is 2, most likely is 5, and pessimistic time is 14. And then F, starting node is 5, end node is 6, 5 and 6. Optimistic time is 2, most likely is 5, and pessimistic is 8. Okay, and 1. So you see, when you have activity on arrow as presented by this, the best is to use start or end node numbers. Just to make sure that we have the numbers correct: 17, 29, 47, 6, 12, 24, 16, 19, 28, 13, 16, 19, 2, 5, 14, 2, 5, 8. Okay, once we're done, we click solve. And here is our early start, early finish. Okay, and here is the slack, the standard deviation, and the variance. So let's look at, first of all, the total estimated time is 64. See, project duration estimated to be 64. That's correct. Yeah, the total estimated time is about 64. The most likely time, which is the activity time, most likely time is 30 for A, 13 for B, 20 for C, and as you can see, the computer has calculated correctly. T is 30, 13, 20, 16, 6, and 5. 30, 13, 20, 16, 6, and 5. So these are the weighted average of the 3 times. Okay, and this is the variance. The computer has calculated that for us too. 25, 9, 4, 1, 4, 1. Okay. Now, the variance for the overall project, would be the total of variance for the critical activities. Critical activity is activity A, B, D, and F. So the total variance for the critical activities is 25, plus 9, that's 34, plus 1, that's 35, plus 1, that's 36. So the variance is 36. Square root of variance is standard deviation. So square root of 36 is 6. The standard deviation for the project is 6. Okay. So we have calculated that n. Here is the variance, here this weighted average time. Now you can use this to calculate the probability of a project finishing at a certain time in comparison to the estimated time, which is 64. Okay, but before we go there, let's look at the graphs first. We look at solution. If we click on charts and then click on precedence graph, it shows us the network. So 1 to 2, 2 to 3, 3 to 5, 6, 2 to 4, 4 to 5, 5 to 6. And as you can see, the red arrows represent the critical path, which is 1, 2, 3, 5, and 6. And then we can click on the Gantt chart. Again, it presents us the critical path, which are bars in red, and the other path which are not so critical because there could be some delay from early start and late start. So there are some slack that you can use to kind of, if you need to reallocate or reschedule the use of resources to more critical activity, you can do that because you have some room for delays. Okay. Anyway, so that's the chart. And activity time computation, these are the activity time computation. Okay, this is the variance for each of those activity. You can calculate the standard deviation by square rooting the variance. This we have done that. Yeah. Now let me go back. Yeah. Let me go back here. So with this, I say we can ask the question of finding out the probability of a project finishing at a certain time. So let me bring up okay, let me bring up my Excel here. Okay, so remember the weighted average estimated time is 64. We can ask the question, what is the probability of the project finishing on day 67? Okay, what is the probability of the project finishing on day 67? We can use this formula to calculate that. The formula is TS, which is the day of finishing, minus the weighted average finishing time, 64, divided by square root of the variance of the project. Remember, the variance of the project is 36. Square root of 36 is the standard deviation, which is 6. So basically, divide by the standard deviation of the project. Yeah. So 67 minus 64 is 3, divided by square root of variance of the project, or divide by standard deviation of the project, which is 6. Yeah, standard deviation of the project is 6. So if we do that, what we get is a z value of 5.5. So what you can do is you can use the z table to find the probability. Yeah, for probability. Let me take you to the z table. If you look at 0.50, the probability of finishing on day 67 or lower is 69.15. 69.15%. Yeah, that's the probability of finishing the project on day 67 or less, yeah, or earlier. And we call this cumulative probability. Cumulative probability. Probability of finishing on day 67 or earlier. Remember, the estimated time is 64 days. We can calculate this probability without using the table, by using Excel function. So what you do is you go to formula, yeah, look up, if you use statistical function, statistical, and then look for normal distribution. Okay, normal distribution. X is the time that you would like to know the probability of finishing on, yeah. day 67, which is found in C5. The mean or the weighted average time is 64. It is found in cell C4. Standard deviation is, okay, actually, let me just put this here. We say the variance is, what was it, 36. And so the standard deviation is square root of 36. So standard deviation is 6. So here we can go statistical. We look for normal distribution. Okay. X time is 67. The mean time is 64. Standard deviation is 6. Cumulative, we use the symbol true. True means we are looking for the cumulative distribution function or the probability, the probability that the project will finish on day 67 or earlier. So it's a cumulative from day 67 and lower. Let's go back again, normal distribution. X is 67, mean time is 64, standard deviation is 6, and cumulative is true. Okay, and we click OK, and you can see the number that we get is similar to what we get from the table. It may not always be the same. Remember, when we're using the table, the z value is 0.50. So we have the exact number there, but sometimes this is using only 2 digits. Sometimes the z value can be more than only 2 digits, and so we're going to have some differences in the number due to rounding. But anyway, what if you want to find out the probability of finishing exactly on day 67? Probability of finding that the project will be completed exactly on day 67. You will need to use the false logic, logic symbol. So normal distribution, X is 67, and you would like to know the probability of finishing exactly on day 67. So here we say we are not looking for cumulative. We're looking for the exact. The probability of finishing exactly on day 67 is only 5.87%. Why the difference? Because 5.87% is probability of finishing exactly day 67. The remaining, the difference between these are the distribution of probability of finishing on day 66, 65, 64, 63, 62, and so on. Yeah, and so on. So if you'd like to know what is the probability of finishing exactly on day, let's say on day 60, yes, you can. It's only 5.32. What if I would like to know the probability of finishing exactly on day 64? It's 6.65%. The cumulative probability is 50%. Okay, and so on. So that is basically how you use a normal distribution function to estimate the probability or likelihood of finishing on a certain time exactly, or finding the cumulative probability. Okay, I will end this video now, and I will share this with you on YouTube. Thank you.